So we're looking at the Olive Mark I and the Magnolia Mark I Arduino sensor board and USB breakout board. We'll first look at the Olive, and this is the Olive close-up. You can see here that it's running a FTDI USB chip on board with a regular USB connector. It's got a female end to prevent shorts, and right there you can see is a jumper. That jumper will allow you to switch from 3.3 to 5 volts depending on what your application needs. We're going to make another video where this connects to a Texas Instruments MSP430 LaunchPad. For this particular video, we're going to connect it to our Magnolia, which is basically a really simple Arduino board with a sensor breakout. So here is the Magnolia. It's got the oversized LEDs that you can take out, or you can break those out into their own wired LED configurations. We didn't want to do surface mount LEDs because they're just a bit too hard to customize for your applications. This way it's really easy to take those out and wire them into your box if you want to. Also, we didn't want to do a surface mount at Mega chip. We wanted to make it real easy to take this chip out, put a new chip in, do whatever you want with the chip. It's really easy to take that out. It's a at Mega 328 PU. One of the better chips that can work with Arduino. We also have on the other end the sensor breakout right here, and we've got 6 positions. We're going to do a demo where this will connect to some really simple software that will allow you to get some sensor input from a sharp proximity sensor. And there you go. This is going to conclude the demo of what we're looking at here for this. And you can use this Magnolia sensor board with other USB breakouts if you want to, or you can breadboard it. We wanted to have the flexibility there for people to do whatever they wanted to with this board. And the same goes for the Olive. You can use this Olive with other boards or our boards and interchange them as needed. So that way you can only buy you could just buy one of these and multiple Magnolias, or vice versa. So now we're ready to connect the sharp proximity sensor. This is a proximity sensor we got on eBay. It's the GP2D-I2 sharp proximity sensor, which is really common in robotics due to its inexpensive. It's really cheap to get. So we've got 3 wires here, and we're going to plug this into the Magnolia breakout, which is right down in the bottom here. All we need to do is find the power, and the power is this one right here. We're going to stick that into where it's labeled VCC. And the black cable is the ground. So we've got the labels here. So we're going to put that into ground. And finally, the sensor cable is going to go up into that top hole there. And there we have it. We have everything in place. Put that middle one in a little tighter. And we're now ready to take some readings. The next thing we need to do is put some software together, and we should see some output. Here's the code for the sensor attachment, which we're attaching a sharp infrared sensor, proximity sensor, and we're connecting that to the analog sensor board on the Magnolia. and the Magnolia is connected right now to a Olive, which is basically an FTDI USB board. And as you can see, it's a fairly simple program. We're basically setting two global variables, the sensor pin and the sensor value. We're initializing the sensor value as 0. That's going to change as input comes in through the proximity sensor. The serial.begin is basically saying, hey, let's set up a serial connection. Let's make it at this particular baud rate, which is fairly fast. And for the loop, we're then changing the sensor value to be whatever is coming in through analog read sensor pin. So sensor pin we defined at the top as A0. Analog read is saying, hey, let's read what comes through this sensor pin. So analog read is a great simple Arduino command for reading the input variables as integers from the analog board. The serial.println, print line, is just outputting the results to the terminal in Arduino, and you can create software that reads that port really easily and do what you will with it. The delay down at the bottom is basically saying wait 100 milliseconds before you read this again. So that way you can control the speed by which your program gets that sensor information. So if we actually download this to our boards and take a reading, I'll move the terminal into what you're actually seeing here. So here we're seeing values coming in from the actual sensor, which is a sharp proximity sensor. And I'm going to move my hand in front, and as you can see, the numbers, as I move my hand in front, the values get larger. Move my hand away, the values get smaller. So you can see the granularity there as I move my hand up and down against the proximity sensor.